Okay, so for question 3, so you're given this circuit diagram here. You're asked to find the total resistance as seen by the voltage source Vs. Okay, so this side you have R1 and R2 in parallel, and they are in series with R3. And on the left you have R4. Okay, and then circuit part B, total current IT. Okay, IT is here. You have to refer to all the labelings on the diagram. Okay, IT supplied by Vs, and then the current IR3 is here, flowing through resistor R3, and the voltage VR4 across resistor R4, which is this. Okay, so if you look at the diagram here, on the right side you have R1 in parallel with R2, and then these two resistors, they are in series with R3. Okay, so on the right side you can simplify as this. So on the right you have this, you have R1 in parallel with R2, and you have R3. Okay, and in the middle we have this voltage source and a resistor. Okay, so then you have this on the left. So here we have R5, R4, R5, R4, and this is your Bs. So on the right hand side, you know you have R1 parallel with R2 in series with R3. So this is 3, R3. And this 2 point here, okay, because of this 2 point, right, you know the left and the right are in parallel. Okay, R4, oops, yeah. R4 R4 is in parallel with this on the right side. So you can simplify, right? You can simplify. So R1 in parallel with R2 plus R3 in parallel with R4. Okay, and the whole thing in series with R5. Okay, and the whole thing is series with R5. So then you, if you want, you can redraw the circuit. So you have your Vs here, and then you have R5. Then R5 connect to this part here. So you have Vs, you have R5, and this is actually R4 in parallel with the right hand side. Whatever you see on the right side, which is R1 in parallel with R2. Okay, maybe I will write below. So this here, this R here is given by R is equals to R4 in parallel with R1 plus, so R1 in parallel with R2 plus R3. Okay, the whole thing here. Okay, never mind, I will write this. So RT is equal to R5 in series. Okay, with R is given by R4 in parallel with R1 in parallel with R2 plus R3. Okay, so you have an inner bracket here if you want to put. Okay, then next is to substitute the value. R5 is 26 ohm plus R4 is 40 in parallel with, now R1 in parallel with R2. You can work out R2 is equals to 20 times 80, right? Divide by 20 plus 80. So you can work that out. What's the value? It's 16. Okay, it gives you 16. So you can substitute 16 here plus R3, which is 44 ohm. Okay, 44 ohm. So then with that, it becomes 26 ohm plus 60 in parallel with 40, right? So 40 in parallel 60, same thing, 60. And then you may want to put a ohm outside. Then after that, you compute it. We do 26 plus 24. That gives you 50 ohm. Okay. So you should expand your answers, like 40 in parallel with 60. You can work it out like what I've shown you here. R1 in parallel with R2. So that's RT. So part B, to find IT, you use Ohm's law. So it will be Vs over RT. Since you already computed the voltage, no, the resistance, right? The total resistance. So supply voltage divided by total resistance, that will give you the total current. So it will be 15 volt divided by 50 ohm. So that gives you 0.3 amp. I noticed when I checked your Classkick submission for the self-practice question last week, some of you do not indicate the intermediate steps. Okay, you did not indicate the intermediate steps. So my advice to you is to indicate the intermediate step like what I've done here. Okay, so in case your final answer there's some calculation error, you still get marks. And also for revision, it's something you can refer to. Okay, something you can fall back and revise. Then for IR3, you can apply CDR. Remember current divider rule? Okay, so by CDR, IR3 will be equals to IR4, which is on this side here. Okay, IR4 on this side, right? On the right. Current divider rule is applicable to parallel circuits. Okay, when you want to find a current in a loop, when you know the total current. So now you know the total current here. If I refer to this diagram, you know the total current, right? IT here. You know IT, right? Then the current will branch out from here and here. So you have I3 here, and then you have I4. Okay, current through R4. So you apply CDR. Let me change the color. You apply CDR. So that will be R4 divided by all the resistance are in the two loop. So will be R4 plus the resistance on the right hand side, which is this part here, which is this part. Where's my mouse? Which is this part here. Okay, R2 in parallel with R3. So you put it down. R4 plus R1 in parallel with R2 plus R3. Okay, the total resistance on the right hand side. Multiply by IT. Okay, that's your current divider rule. So from here you can substitute the values. 40 multiplied by 0.3 amp divided by 40 plus So you have 20 in parallel with 80 plus 44. Okay, so you substitute the values and use your calculator to press. You should get 0.12 M. Okay, that is IR3, current flowing through resistor R3. Okay, part D, voltage VR4 across resistor R4. Here you can apply KVL. Okay, you can apply KVL. Let me erase certain parts here so that I have some space. That's my eraser. Can you give me a moment? The erasing part here. Okay, for part D, VR4 is the voltage drop here, right? Positive, negative. Okay, so because it's in parallel with this 2 point, it's in parallel with this. If you subtract the voltage drop across R5 from the supply voltage, that will give you the value of VR4. Okay, so from here, VR4 is equals to Vs minus IT, which is the current flowing through R5, multiplied by R5. Okay, so substitute 15 for Vs, and then IT is 0.3 M, multiplied by R5 is 26 ohm. So that will give you 15 minus 7.8. That gives you 7.2 volt. Okay, 7.2 volt. So this one you can bracket them and put a V there. Okay, so R4, the voltage drop across R4 is equivalent to the voltage drop here because they are parallel. So Vs subtract the voltage drop across resistor R5 will give you the voltage drop across R4. It's the same because they are in parallel. So here it is 7.2 volt. I think 7.2. Okay, the 7 keep running. This is 7, 7. Alright, check your answers.